Good day, my dear STEM students. For today, we'll be discussing all about the mathematical ways of expressing concentration. Okay, so I have here the different examples on how to solve mathematically the concentration of solution. Number one is percent by volume. Number two is percent by mass. And then number three is molarity, followed by molality, dilution, and the mole fraction. These are the sum of the ways of expressing concentration mathematically, but there are so many ways. Okay, so we will discuss, or we will going to concentrate first on how to compute for the molar concentration. Okay, so what is molarity? Molarity of a solution is defined as the number of moles of solute dissolved in 1 liter of solution. So molarity is mathematically expressed as moles of solute divided by liter of solution, or in symbol, that is M is equal to N over L, wherein N stands for the moles of solute. So in every 0.25 m or molar is same as 0.25 mole per liter. This is the dimensional unit of 0.25 m. Okay, and then take note, in solving for the concentration in molarity, all volume units should be converted first in liters before you use the equation M is equal to N over L. So I have here the conversion factor and how to convert volume units. Okay, so for every 1 liter, there is 1,000 ml, and that is equivalent also to 1,000 cubic centimeter. Just in case you need the unit for mass, I have also here the conversion factor being used in converting the mass unit. Okay, so for our first example, what is the molarity of a solution prepared by dissolving 1.5 mole sodium chloride in enough water to prepare 500 ml of solution? So for our given, we have here our moles of solute, which is 1.5 mole, and then the volume of solution is 500 ml, and our required is molarity. Okay, the equation is M is equal to N over L. So how to compute for molarity? So since our volume is in milliliters, you have to convert first the volume of solution to liters. So this is how to convert. So 500 ml, every 1 liter there is 1000 ml. And cancel the unit, and then you will get 500 liters. And then now we can use the equation. And then for M is equal to 1.5 mole, that is your N, divided by 0.500 liters, then you will get 3. Since our least number of significant figures in our given is 2 significant figures, so just simply add 0 in your final answer. Okay? Next, calculate the molarity of a solution for which enough water is added to 8.0 grams of sodium hydroxide to prepare 100 ml of solution. The molar mass of sodium hydroxide is 40 gram per mole. In this particular type of problem solving, we do not have the number of moles, but instead, we have this mass of solute. So that is our first given. So our volume of solution is 100 ml. The molar mass of sodium hydroxide is 40 gram per mole. Okay, so the required is compute for the molarity, and then equation is M is equal to N over L. Since we do not have the number of moles in this in our given, we need to use another equation in computing for the number of moles, and that is number of moles is equal to the mass of solute in grams divided by the molar mass. Okay, let us start computing. We have to solve first for the number of moles and the liter of solutions. We cannot use this equation if we do not have these two variables in moles and liters. So you have to convert first 100 ml to liters. Then you will get 0.100 liters, and then compute for the number of moles by using this formula. N is equal to the mass in grams, mass of solute in grams divided by the molar mass of solute, and then cancel the unit in grams, and then you will get 0.20 moles. Since we have already completed all the variables needed, in our given equation, you can now substitute all given values. Okay, M is equal to 0.20 mole divided by 0.100 liters, and then you will get 2.0 mole per liter, or 2.0 m, or 2.0 molar. Okay, so in our next problem, this is what you call the solution stoichiometry, wherein the molar concentration is being included in the given problem. Okay, how to solve this particular type of problem? So our given is volume of solution is equal to 500 ml. Okay, concentration in molarity is 2 molar, 2 molar hydrochloric acid. So we all know that this the dimensional unit is mole per liter. And then finally, the molar mass is equal to 36.45 gram per mole. So these are the given. Okay, and then required the mass of solute. This time we are going to compute the mass of solute. We are not computing for the molar concentration of the solution. Instead, we need to know the mass of the mass of hydrochloric acid. Okay, so equation. So we're going to use our dimensional analysis. So given volume, multiply it the liter conversion, then you will multiply it to the concentration in molarity, and then finally multiply that to the molar mass ratio. So for our first value, given volume is 500 ml, and then liter conversion, next step. So for every 1 liter, there is 1000 ml, and then cancel the unit ml, then followed by the concentration in molarity. Okay, so our concentration in molarity is 2 molar, and 2 molar is also same as 2 mole for every 1 liter. Then cancel the unit liter, and then finally you will use the molar mass ratio. Okay, so for every 36.45 grams, there is 1 mole of that particular substance. And then cancel the unit of mole, and we will get 36.45 grams. Since the starting amount is 3 significant figures, your final answer should be 36.5 grams. Okay. Next, what volume of solution is prepared from 2.0 grams sodium hydroxide with molar mass 40 gram per mole with a concentration of 0.6 molar? Okay, given mass of solute 2.0 grams, concentration in molarity 0.6 molar, then molar mass of solute is 40 gram per mole. Okay, required volume of solution. Okay, so our dimensional analysis, mass of solute is multiplied by the molar mass ratio, and then multiplied by the concentration in molarity. So our mass of solute is 2.0 grams sodium hydroxide. Okay, this is the molar mass ratio, which is 40 gram per mole. Cancel the unit gram. Then lastly, our concentration in molarity, for every 1 liter, there is 0.6 mole. Then cancel the number of mole, then you will get this particular value. So since our starting amount is 2.0 grams, this is 2 significant figures, so our final answer should be 0.83 liters. So for any questions, just leave your question in our Google Classroom. Then stay safe, stay at home, and God bless everybody. Thank you.